Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about CV engine or constant velocity internal combustion engine. So let's dive deep into it. Now, we are in an era where we are hating ICE engines too much, and whenever you see ICE simply means internal combustion engine. It could be size agnostic, it could be fuel agnostic. So ICE simply means it's BEV means battery electric vehicles, FCEV means fuel cell electric vehicles, ICE vehicle means internal combustion engine vehicle. That's all it means. That's why this term you will see a lot: ICE engines, ICE vehicle. That's what they're talking about. Now, it's a groundbreaking innovation. Fundamentally speaking, taking the idea of liquid fuel, converting into rotational energy, and a lot of rotational energy, that's literally propelled humanity to industrial revolution. So same way the importance of electricity, same way the importance of steam engine, internal combustion engine is on the same level. It is significant. It's not something that's like it was a minor. Nah, it's a major innovation for humanity. And to give you a context of that, there are companies who are spending millions to billions of dollars annually to refine this puppy. And that's why F1 is still going on. Like, fundamentally speaking, the amount of research and development that goes into ICE is reasonable because of its importance, because of its scope and the capacity it yields. Basically, we got our wings with internal combustion, not jet engine. Jet engine came way later. So this is how we started to fly. So this four-stroke system is a very backbone level technology for us. So be it Rudolph Diesel from diesel engine, be it Henry Ford with basically a proper mass-produced car engines, literally it is very important. A lot of people have poured a lot of soul into it, a lot of research into it, and now we have an internal combustion engine that is reliable. So it moves everything from people to cargo, from train to ships to bus to cars to trucks. And whenever you are talking about big units like giant cargo ships, warships, or like locomotives, things of this, basically big natures, yeah, they are not going anywhere. Let that be very clear. They are not going anywhere. I explain that further, but they are not going anywhere. So it comes in many shapes and sizes, and also fuel types. For example, if you're in a scenario where it's like, hey, your country dumps excess renewable into hydrogen for production, and then you have surplus hydrogen. Hydrogen for production simply means hydrogen that is consumed for industrial use, like manufacturing, food, metallurgy consumes a lot of hydrogen. Like, I was shocked. That's how much hydrogen it consumes. So we need hydrogen for those things. But let's say you have some surplus, you can still put hydrogen gas into an internal combustion engine, or you can even carry liquid hydrogen as Toyota did for race, because again, you do want your race engines to be like very loud and proud. So they took liquid hydrogen and put it into combustion engine. Yeah, so you can do that. It's fuel agnostic. It does not care. You can put it in jet fuel, you can put diesel, you can put petrol, you can put ethanol. It does not care. By the way, somebody has actually built a ammonia based engine also. So it really does not care. Of course, it does require some tuning and tweaking, but it does not care. It's like very agnostic. If you give it carbon neutral fuel, it becomes carbon neutral. You give a carbon positive fuel, it becomes carbon positive fuel. So it's internal combustion engine. Very important, very significant, and hating it for its sake of hating it is missing the point. So what we are talking about here? We are talking about CV engine. Now, fundamentally, the core principle is changing the crankshaft. Basically, they are taking, if you look, slice engine, whatever engine, motorbike engine, car engine, whatever have you, generally it has a piston that is going up and down, up and down. Now, here's a problem. Your things require rotation. You do not want things to going up and down, up and down, up and down. So how the heck you convert linear motion to rotation movement? That's how we utilized crankshaft. Now this technology is refined, matured. We have been doing this for 1 century, and we have reached a point where it's like upper limit of its efficiency has reached, meaning we cannot push this much further. We reached that point where it's like, bro, it's saturated, so to say. So what CV design does is basically yields the center part. Everything else, basically your piston heads, your air intake, your exhaust manifold, all of those remain the same. You just yeet the center part out of it, and now you have this motion device. Now it looks very weird. Trust me, I've linked the video down below. It will still look weird. It fundamentally looks weird because what they have, this cage structure you have, it's offset. So cage is not like this. Cage is like this. So cage is offset. So in one stroke, basically in one push direction, the lower part applies. The pull direction, the upper part applies. So that's how it's changing the oscillation of basically the pistons to rotation, and it's very well constrained, so there will not be any chattering. Very linear, meaning from piston's point of view, piston is not fighting. That's the core selling point of this. Piston is not fighting the piston walls. So whenever you see pistons, you will see the ceiling ring is there, and then you have cylinder wall that is fighting with the piston, and that is friction point. And be mindful, we put a lot of oil there, that also gets consumed because there is a lot of friction there. So if you reduce that, that's a significant amount of energy wastage there. So basically somebody figured out, it's like, what if we take this part, heat it, put this new design in. This is what we are talking about here. Everything else will remain Control C, Control V, but this part is changing. So new path of linear motion to rotational motion. Basically, you are eating the crankshaft. Now, what is the benefit of doing so in this design? In this design, you have less RPM, meaning if you want X amount of power, you can get the same amount of power with half the RPM. Because how it's working, you only require half the RPM. You're getting far more oomph out of it, and less fuel. Again, less RPM, less fuel, all of that is there, and more power is also there. Because of how the power stroke is being transferred. Basically, in simplest sense, I can describe this as basically this is a small handgun, this is a rifle. Now, if you know about weapons mechanics, you know for a fact that pew pew, that is the powder that is used for your hand pew pew, it literally is fast burning. When you compare that to rifle is slow burning. You're like, wait a minute, why? That's the whole point. It expands, couples the basically velocity to the projectile far more effectively, and that's what's happening here. You are coupling the hot expansion gas to the piston. Now here you have some limitation, because again it's not lateral movement, you also have chattering going on. So there is a limit how much you can do. Here it's push as hard as you can, and that literally evacuates the other part, that pushes as hard, evacuates this part. So it's a very simple, so to say. So less RPM, more power, and it has less pollutants also, because again the amount of oil that this will probably consume would be less. Again, you do not have giant friction spot for basically cylinders and all that. So there is serious potential here where you're going to have low NOx emission and all that. Because many times people will say against biofuel that while biofuel fundamentally removes the carbon problem, we'll no longer have the carbon dioxide problem, but it still has emissions, basically sulfur dioxide and nitrous oxide and all that. And we try to suppress it by utilizing basically catalytic converters. We try some tips and tricks to take care of it. So here, if the fundamental engine, the core engine head is not making too much pollutant, that is a good thing. So these things can, in principle, clear the emission regulation without catalytic converter. Add catalytic converter is like clean. Don't even worry about it. It's pure clean. So on principle, let that be clear. That's on principle. Now, what about the patents and all that? Yes, they are loaded in that department. So you have US patent, the website I will link in the comments. You can check the patents number and all that. So US patent is there, Japan patent is there, Germany patent is there, France patent is there, Italy, Great Britain, South Korea, and India. So yeah, they are loaded in that department. So patent is done. This is the engine principle. Basically, you take the same 4-stroke principle, you just yeet the crankshaft, and you can watch the animation as much as you want. It's weird. It will look like, what the hell is happening? So, but just remember this, it's not a linear slide that is going like this, it's an offset slide. Again, it's a one piece, but it has offset. That's why only one engages at one term, another engages on the other term. So this is CV engine. Now question becomes, why the heck work on combustion engine at this point? Well, if the predictions are correct, let's assume the predictions, what they are claiming, what their mathematics are showing, what small scale testings are showing, all those are true, it's going to be a significant progress over the normal conventional internal combustion engine. Combustion engine on papers are very efficient, but in real world they are not. Now imagine something significant upgrade. For example, my car claims a very large amount of number, like kilometers per liter. I barely get 19 kilometer per liter. Now this is a tested metric, because I have a fixed distance that I travel, and route is fixed, everything is fixed. Every few months I have to do that. So it's a fixed full tank to full tank. So I'm barely getting 19. Now imagine that became 25 or 30, like significant upgrade. People will simply say, shut up, take money. And because of the amount of internal combustion engine that has in active use at this point in time, it's significant. If you can improve it, that will drastically reduce the emission problem that we are dealing with. It will not eliminate it, but reducing it is better than doing nothing. And I'll talk further why a battery system could not just like poof all the problem, even though we have been trying for 20 years. I'll explain that further. So if there is a significant probability of improvement, not doing it is harmful to the planet. Because again, there are reasons why you cannot just yeet internal combustion engine. People have been trying for almost a quarter century. So there is a reason there. And in terms of electric vehicle, there is a great advantage you can have. You can have a very small range extender. Imagine an engine that is very efficient, very small, very compact. And what does that mean? That simply means it's a small thing that you can put in your trunk. Right now, electric vehicles say they have like, frunk and trunk. What if they no longer have the frunk? They just have a range extender there. What does that mean? That simply means biggest primary failure of electric vehicle was range competition. Every company is like, my range is bigger than yours. Problem is, as you make your battery bigger to have more kilowatt hour capacity, the more kilowatt it consumes just to move. Meaning if it's a let's say 50-kilometer range battery, it would be light. It would be like, bro, I'm barely consuming few watts to move. Now you make it 100-kilometer, now it's consuming a bit more energy just to move. Now you're like 200, now your battery is like literally same weight as the car. Not the full vehicle, just the battery itself is the same size as a car. Yes, that's how big these are. And then like 500. Now it's so heavy. It's like the tires have to be specially designed to handle that. Look into Audi SUVs and all that. They are like, yeah, it's heavy. Look into electric trucks. It's so freaking heavy that it's like road companies have to create a dealership with not dealership, as in like a deal with US government. Is like, hey, if these things run on our road will be destroyed. You have to create a different weight class. So you cannot just increase range. So what could have been done? Well, this was an old concept in like 10-15 years ago. Videos are linked down below. So the idea is you have an electric vehicle, normal electric vehicle, nothing fancy, you small range. You go YOLO on it. You enjoy, like for example, even in my case, I have a Maruti Espresso, simple car, very simple consumption. Most of the time, I do not drive more than 20 kilometers per day. It's not happening. It's not happening. And even if you're living in the metropolitan and all that, it's like, who are you who is driving, other than taxi drivers and all that, who is driving that much? And be mindful, even taxi driver, kilometer by kilometer, it's not that much. Only sometimes it's like, okay, long drives and all that. So the idea was you're going to have your car, small range. So your per kilometer, how much kilowatt you are consuming, it will be very little, as mean how many unit you can consume, it will be very little. And when you need to travel, you're going to have a range extender. Now, if you have an engine, combustion engine that is much more efficient, much more compact, much more like, robust, so to say, now you can have just like that small thing in the front unit. Voila. And it only turns on like a series hybrid system, where it's like, hey, your car is running fully on battery. Now your battery is extremely low, no charging station, crank the engine. So it's a very good range extender technology. It's like shut up, take money. Because right now this range competition is harmful to electric vehicle and harmful to everybody's pocket. It's like, it would be far more cost effective. It's like, hey, just 100 kilometer. Don't give me more than that. Just 100 kilometer, and all the battery weight that you will give me like 500 kilometers, 600 kilometers. Like, don't even try. 100 kilometers, or let's say 150. You want to be like, very cautious. 150 kilometer. Give me a small fuel tank, small engine, generator unit, just so I do not have to recharge. Like, again, this only small. Again, that does require a small unit. So it can be done. It's a very awesome technology for that. And there are only few companies. This comes to the economic independence part of a country, is that there are only few companies that make engines. Even though there are hundreds of car brands, there are very few companies. Like, India has a lot of car brands. We have Tata, we have Mahindra, we have others also, smaller players. But you get the point. Like, we got it. And I was shocked to realize they do not got the engine part. Now, it's not that shocking given the fact that Russia is having problem with engines. There are only few companies that know how to make a high reliability, high efficiency combustion engine. Like, surprisingly few. There are far more motor vendors than there are engine vendors. Like, Fiat engine is like almost the daddy of it. And there are like 2-3 main models done. You could literally go through car from one brand to another brand. Engine would be like, same bruh. Look into it. What's the engine of Rolls-Royce? It's not Rolls-Royce. So that's the whole point. There are only few companies that know how to make engines. So a change is desirable at this point. Again, for the companies also, for example, companies that are buying the engines, if they have a second supplier, they can negotiate the price, or they'll have better negotiation deal. Right now, they're like, they have to pay it. The engine brand is Suzuki. It's not. It's a Fiat 1.3 multi-jet engine. So you get the point. Like, there is a very serious stuff. Basically, think in this way: how Android phones are not actually Android phones. They are actually ARM phones made by mostly Snapdragons, sometimes MediaTek, and sometimes Samsung SNOs. But that's the whole point. But you have so many brands. You have Oppo, you have Vivo. Again, they rarely make their own SoC. So same thing goes here. SoCs is not being mass produced as often as brands are. So that's there. Now, aim is of this company, CV Systems, is they're gonna be the OEM providers. Basically, either they're gonna make the engine, design the engine, and give you the full engine, or just lease out the patent to other manufacturers. It can be, again, it's a normal thing to do in the industry, where it's like, okay, I have the patent of this works, we prove it, it's a desirable thing, then people pay for that patent. It's that's why there is such an interest for this. And yes, India is playing a big role in this. And again, be mindful, it's a legal thing to do. Basically, they are not like tricking the audience. It's a legal thing to do where like you can't claim that Samsung is tricking you if they utilize like, Snapdragon system. Like, that's what it is. So what amount of progress have been? So far, everything is theoretical, the CAD modeling and all that. So they started with the first proof of concept, that is AA01, this puppy. Now this puppy is proof concept. Like, you have decided that I can turn basically linear motion like this to rotational motion. I'm pretty sure you must have seen hundreds of YouTube shorts where they have like weird mechanism. The question becomes, is it actually real life suitable? So this tabletop model was a proof of concept where it's like, does it actually work? Basically, can this system of sequence does work? It did work. So at this point in time, proof of concept has been done. Like, it does work, we can scale it up, we can try next big things. So now there are two players are at this, USA and India. In India, specifically Bangalore, where they're building the physical unit that will be used for a vehicle, basically a three-wheeler. Now the reason is it's a two-cylinder, four-stroke, 186cc system. Now, like, hey, that's too small. Yeah, auto does not require a lot, and given the conversion efficiency that they are hoping for and the torque improvement, it should be more than enough. And again, this the primary target of this prototype, this two-cylinder, four-stroke prototype. It's very simple. Does this work under load? Like, this is good and all, this proves the core concept. Now, does it still work under load? That's a next big step. So that's what they are working on right now. As of now, when I'm making this video, this should be done in few months. Hopefully, knock on wood, before this year is out, we should have an actual vehicle running on this. At least figuring things out, as like what works or what does not work. So that engine is under construction, and it will be full scale test. They have prototypes, small test, and the idea is that you're gonna achieve that crank roll off, so to say, will become flattened, and that will also improve the gearbox, meaning we will no longer need multiple gears. Well, like few gears should do the job. So that's the progress that we are expecting right now. So it's no longer, oh, somebody made a design, somebody a YouTube video. No, there are people, there are companies working on it, and some other companies also, OEMs, that they have shown. It's like, yeah, we would buy that if you prove that it could work. So there is a serious amount of interest. Because be mindful, it's like there's only ARM and there is x86. There is nothing else. Think about it. There is ARM and there is x86. Now you'll say, oh, there's PowerPC for IBM. When was the last time you used a server or a computer that had that? Like, it still exists, it's real, it's just that good luck finding it. So that's the whole point. There is a very serious hunger for new technology and new efficient engine. Shut up, take money. So what can we expect in the future? Well, reality is the R&D that is going into combustion engine, it's not going anywhere for a while. Now, what is this while? Let me define it. Bare minimum 50 years. Now, the primary reason why basically battery vehicles did not took over as quickly they should have. Like, think about it, like how the marketing was 20 years ago. It was like, the new millennium has happened, battery systems are happening, global warming is happening. It should have worked. Why the heck it did not work? Well, reality is we did not did this. Somebody looked into F1 and looked into the parallel hybrid model, and that's what they released at the first time. That was the first vehicles released, and they were so messed up. Again, inherently, they forgot the first rule of engineering. It was not KISS. They did not keep it simple, silly. It was super duper hyper complex. Many of the hybrid models that Toyota, Honda, Chevrolet, and what other brand was also, they released, they had clutch packs on an electric vehicle. You have freaking clutch packs. And here's the deal, this is how you should have done. What this gentleman did, I am very happy. And basically this gentleman did is like, hey, let's take an electric diesel locomotive, which has been running for almost a century, just put batteries in front. That's it, nothing else. You take diesel electric locomotive, you just put batteries in. That's what he did. He built this truck, got it Canadian government verified before Elon Musk promised his delivery. Basically, he actually put money down to get a truck, and then because again, he's an actual trucker, he's like, hey, I would not do this like this. And he complained, and then people are like, hey, if you think you can do better, do it yourself. He did it, he built it. And be mindful, that's the exact same thing that is done for submarines. So I have no idea how the heck people got so caught up into this F1 frenzy, whereas like F1 has the same system where you have a combustion engine that has a what we call kinetic energy recovery system. It's basically motor generator unit connected to the crankshaft itself. And nowadays they have thermal energy recovery system, that is turbo energy recovery system. So that is so complex. It requires an engineering team working 24/7 to get that puppy working. And they wanted to put that technology into basically Volt. And people are like, Yeah, it did not sold. Of course, it did not sell. Of course, it cost bankruptcy to the bankruptcy, as in like it was a very over expensive car that did not turn as much profit as it could have. Why? It was not simple. It was complex. What you need is an engine that is floating. What does that mean? Do not connect it to anything that has changing RPM. You take the engine, you couple it to generator. The end. The end. There is no vibration coming from the crankshaft. There is no different load coming from the crankshaft. You have a generator, it just runs at 1 rpm, 1 torque loading, so you can keep it at what we call island efficiency. Meaning if you take a engine, whatever engine have you, whichever manufacturer it have you, even this engine will have that, whereas like at certain rpm the efficiency is just right, it's perfect. The thermodynamic efficiency would be just right at the just right rpm, just right torque loading. At that point, the most amount of megajoule that can be extracted from the liquid fuel to rotational energy would be happening. You want your engine to be that. That's why diesel locomotive do not have accelerator. They have like notch. Driver does not have to do anything other than that. Engine automatically reaches the RPM, automatically stabilizes, load equalizes, torque applies, everything is chill, everything is efficient. So you have an engine, you have a generator, generator feeds the energy to inverter, inverter figures it out. If the basically the person is applying brakes, it sends the energy to the battery and regen to the battery, and then like person is accelerating and is exceeding the energy draw of what this generator can provide, it drains from the battery. Super simple, no clutch plaques needed, very simple, reliable. Be mindful, we have been doing this, and this gentleman did it before Elon Musk promised, and that's why this is the best system we have. And this is super easy. You can just go to a car company, it's like, hey, make this, and your car will literally go from mileage, like in my case 20 kilometer per liter to almost 35 kilometer per liter, like almost double I can get. Much low efficiency, and again most of the time is small, short range transport. I'll just charge it at home, and again even when I'm traveling for long distance, at that point I'll just, I'm getting the benefit of regen. And at that point in time, most of like, let's say it's 100 kilometer, I have to travel 400 kilometer. The first 100 kilometer was on electric. So flat out electric internal combustion is here, and it's going to be here for a long while. Do not worry about it. Now, big loads cannot be handled by batteries or hydrogen. This is a fact of 2020 world, planet-wide. It applies in Canada, it applies in USA, it applies in India, it applies in China. And be mindful, it's really, really bad for European Union. They have very small, basically sparse population density. What does that mean? That simply means it's very easy for a company to claim that they're going to build a, electric truck. Awesome. You're like, awesome. It's like, it's going to have this much, let's say a container. It can move a legal container without any issue. Awesome. And then you're like, how long it will take to charge? Yeah, it will charge in less than 1 hour. Like, whoa, awesome. What is the charging power requirement? This is where people break. This is like, oh, they just say like, it's a 2 megawatt fast charging. Bro, small villages run on 1 megawatt. Let that sink in. 1 megawatt or 2 megawatt is not something that you can just have middle of nowhere. Like especially in Canada, it's not happening. It's not happening. Not in USA, not in Canada, not in Europe. Barely in China, barely in India. You cannot just have like, again, we have population density, so it's happening there. But it's not that easy to just have that much copper, that much transmission line, that much substation, that much transformers. Lol. We're just gonna have like, and that's one truck, by the way. One truck. The amount of energy these trucks consume is significant. That's why we rely on internal combustion engine. Because we talk in horsepower, again, we think we should move to kilowatts, so people will have far more context. It's like, it's a lot of energy. Like a lot. Like you're talking about like 250 kilowatt of energy, which is the transformer rating for this whole block. 250 kilowatt is just consumed by this puppy. It's like, bro, 250 kilowatt is just one truck. And we have hundreds of trucks. So let that be very clear. You cannot run this on electricity as of now. We need to like turbocharge our generation, exponentially boost our grid, exponentially grow all the link connections. Then maybe you will be able to handle it in the next 50 years. So as of now, in 2020, battery is not happening. Now, if battery cannot happen, the next thing people jump to is hydrogen. Yeah, law of physics, unless that changes, that's even worst idea. For example, you take 100 kilowatt hour from government, whatever your national grid, whatever the source may be, let the source be YOLO, it be solar, be it wind, be it whatever. You take 100 kilowatt hour, you dump that energy to Tesla Model 3, distance, how much distance you can cover, that is 433 kilometers. Not bad, not bad. It's good, it's useful. Now you take the same amount of energy from the government, 100 kilowatt hour. Now here's the deal. You have to convert it into hydrogen, and conversion is not a very easy step. You have to convert it into different chemical. Basically, you're taking water, splitting it up, taking the hydrogen. That is 65% efficient. Then you have to pack the hydrogen, because people do not pay attention where hydrogen is in the periodic table. Is the lightest gas. Compressing CNG is child's play compared to compressing H2 basically. H2 is requires a lot of energy. So you are spending a lot of, and again, you have to transport that. It's not wire only. So it's far more expensive in transport, and it's a recurring cost every time you have to do it. And then you're gonna put that hydrogen into your vehicle. And again, vehicle has to do conversion again. It's taking gas to electricity again. So distance travel is 170 kilometers. That is from Toyota Maria. Now, the only reason why would you wanna touch into hydrogen is the two tricks that people utilize. First trick is, this does not put load on the grid. Yes, it does. It just does not put it where you can see it. It's just like it's hiding. It's like, it's the same thing. It's like out of sight, out of mind. So might as well be polluting at that point. It's like, it is an issue. Like solar and wind gonna provide energy. If it is having hard time for this, how the heck is gonna be better for this? It's like, if X amount of energy is expensive, how do you think that X plus 30% or X plus 50% or realistically X multiplied by 5X would be easier? It's like solar panels are not free. I just put 2 kilowatt of solar panel on my roof. Not free, very expensive. Wind, not free, very expensive. So all those things is like energy creation. Wasting it is not acceptable. Now, flat out, it just removes the people's, you're not thinking. It's like where the hydrogen is coming from. The only way where you can have this without any grid downfall is running it on methane. Basically, you are doing steam reforming. At that point, might as well use the methane. It will be far more efficient. So that's the issue here. That's the first problem. It's like, oh, it's not putting load on the grid. It is, it's just out of sight. Another part is that it will be quick recharge. Thankfully, a lot of Indian companies, including Tata, a lot of Chinese company, including BYD also I think has that, and some Australian companies, they also have brain. So what they realize, the big batteries needed for these sort of things will require a lot of energy to charge, or small amount of energy for long duration. That's the another way of charging it. Rather than charging it, speed charging it in 1 hour, if you charge it in over 5 hours, that's much easier. That's for grid is like minor inconvenience. Heck, you can do it actually with solar also. So what they did is just have trucks with swappable batteries. You get the efficiency without the penalty of long wait times. And again, you charge the battery in controlled environment slowly, no issue. And it's far more cheaper. So fundamentally speaking, we cannot just like, okay, we're gonna have locomotives like just pulling giant freight train on battery. Yeah, that's not happening. We're gonna have giant freight train running on hydrogen. Yeah, it's gonna run out of hydrogen every few minutes. Like, to give you a context, diesel is 32 megajoule per liter. Liquid hydrogen barely touches 8 megajoule per liter. Compressed hydrogen, that is like 700 bars, barely touches 5 megajoule per liter. How the heck you gonna carry it? So anybody who's like hydrogen is the future, no, they are the politicians or people who do not do the history. Engineers are forced to work into it, like Airbus. I feel sorry for that engineers. Like, bro, TU-144 was built, flown. We know liquid hydrogen is not a good fuel. And I'm like, or Air Force pilot is like, we built a liquid hydrogen-based fighter jet. We were planning to build B-52 Stratofortress on liquid hydrogen. It does not work. Law of physics is like, brah, you need 160% power output from hydrogen. Law of physics says 100 is not possible. You want 160. Yeah, that's not happening. Transfer the weed. So in 2020's technology, the best technology is this. Short range, long range, this takes care of everything, improves the efficiency, but it does require an engine that is compact and lightweight, so people do not notice it. This engine is a very good candidate for that. Battery and hydrogen, it only works, hydrogen is specific. Battery has a lot of scope, but just like we messed up. Basically, we just have to find that person who like looked into F1 too closely. We have to just boom that person. It's like, bro, look into diesel locomotive. Don't look into F1, look into diesel locomotive or diesel submarines. We have to find the timeline and switch the gear. Just a little bit. Like, look into the teardown of Chevrolet Volt. It's like mind-boggling complexity. I'm like, no wonder this car failed. And it's like, we are relaunching it. It's like we had a bad idea. Then electric vehicle happened. That was again a bad idea. Now we are going back to another bad idea. It's like, just do series hybrid. So there is a lot of future left. Let that be very clear. Lot of future left for internal combustion engine. So we're gonna be here, and any company who cracks some new big things like this company is trying to, there is a lot of scope, more than enough scope of actually becoming successful. That's why I'm kind of excited, like something new is happening. So this was my presentation on basically constant velocity internal combustion engine. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.